So sliding window is a very efficient algorithm when we want to find a specific interval in an array. So we have this Leetcode problem that gives us a string and it wants us to return the longest interval that contains at most two occurrences of each character. So the code starts with us setting both the left and right pointer at the beginning, setting the longest interval to be 1 just to initialize the variable, creating a dictionary, a counter dictionary that's going to keep the characters and the number of occurrences of each character in the specific interval we're checking. The interval will always be the characters between left and right, including left and right. Then we're going to have this while loop that's going to execute while the right pointer is less than the array index. And that happens because we're already going to start the first iteration with the right pointer at the second position. So in that case, we don't have to set it to iterate 8 times because our right pointer is already going to start at the second position. So we're only going to iterate through 7 positions, right? But before we initialize the loop, we are going to be setting the first character of the array as one occurrence, right? So in that case, the first character is B. Our interval is here, so it's going to be something like this, B equals 1. Then when we start the loop, our right pointer will go to the right, so it's going to go one position ahead, so we extend the interval in that case. We're going to check inside the loop, we're going to check if the character we're looking at in the right pointer already exists. If it already exists, we'll just add 1, but it doesn't exist yet in our counter dictionary, so we're going to initialize it with the value 1. This while loop is to check if we already have 3 occurrences of the value we're looking at in the right pointer, but it's not the case, so I'm going to explain that when we reach it. And by the end of each iteration, we're going to calculate the longest interval, right? The longest interval without 3 occurrences of any character at this point is 1, was 1, right? But we just got an interval with 2 characters without this occurrence, so it's basically gonna replace it with 2. So I was checking if the current interval is longer than the last longest interval. Right pointer goes ahead, we extend the interval, we add 1 to B, we check the longest again, we change it to 3. It's the longest interval we've had so far. Right pointer goes ahead, and we add 1 to B, so it's now 3. And now we're gonna enter this second while loop, this inside while loop, this nested while loop. And because we already have 3 occurrences of the character the right pointer is pointing to, right? So what are we gonna do in that case? Well, we're gonna take while we have this, okay, while in that case B still have 3 occurrences, we are going to reduce 1 in our dictionary from B, and we're gonna shorten our interval and move the left pointer ahead, right? In that case, it went right in the first iteration, but you're gonna see through the explanation that sometimes we're gonna have to iterate 2 or 3 times. The longest interval is still 3, right? So we just go to the next iteration, and again we have to add 1 to B. Again we enter the second while loop, and we're gonna have to do the same thing, but now you're gonna notice that we're gonna reduce 1 from the character that the left pointer is pointing to, which is C in that case. So C is 0, right? We want to be loyal to the interval here. The interval that we have now moving forward has no C's, okay? But notice that we still have 3 occurrences of a character, which is B, which is the one that the right pointer is pointing to. So we're going to do that again. And now we're going to reduce from B because left pointer is pointing to B. And we're going to shorten the interval again. Now we have exited this second while loop, and the longest is still 3, right? Because in that case we have a longest of 2, but 3 is bigger anyways. So we move the right pointer ahead. We add 1 to C. We still don't have, at this point, we don't have any 3 occurrences of a character in our counter dictionary. So we just calculate the longest again. It's still 3. So we go to the next iteration and move our right pointer again. Now we have 3 iterations of B, which means we're going to enter again this other while loop. We're going to shorten, add 1 to the left pointer, right? Now we have 2 occurrences of B. We move our right pointer ahead after calculating the longest, which is still 3. Now we have to insert this new element, A, this new character, in our counter dictionary. It's 1. And now the longest interval is 4, right? We don't have 3 occurrences of any character, so we don't enter this while loop. We calculate the longest, and now it's 4. And we return 4, right? Because we have reached the exit condition. The right pointer is no longer less than 7, it equals 7, so we move to that line and we return 4, right? This is a very good solution. We run here, accept it, we submit it, and it was accepted again. Bits 64% in runtime and 50% in memory. It's important to say that this algorithm has an O of n time complexity because the right pointer always advances n times, and the left pointer in the worst case scenario can also at max advance n times. If we got in a string like this, for example, we would also have to run our left pointer through the entire array. In the case that we have analyzed, we only ran a little bit more than half of it with the left pointer, and as always we ran the entire array with the right pointer.